Okay, so the title of the talk is Machine Learning Workflows with HashiCorp Nomad and Apache Spark. And I'm going to be speaking this morning about using HashiCorp Nomad and Apache Spark to enable machine learning and big data analytics at scale. I actually, in hindsight, I might not should have called it. I tend to think about machine learning when I think about Apache Spark because that's actually one of my favorite parts of that library, but it's actually used, as any of the Spark users who are listening would know, it's used for a number of different workflows: batch processing, real-time streaming analytics, advanced modeling, deep learning, machine learning, graph learning, that sort of stuff. So it's a wonderful project. It has a lot of capability, and one of the things that we try to do is to enable our customers who are interested in using Spark and also who are using HashiCorp Nomad to have a better experience with that. So I'm going to go ahead and kick it off. As Nick said, my name is Chris Baker. I am an engineer at HashiCorp. Hence the shirt. And I work on the Nomad team. So if you're listening to the talk and you're thinking, wow, Chris really has a thing for Nomad, full disclaimer, I work on it. I'm also the product owner right now for the Nomad-Spark integration. So if you start playing with this stuff later on, if you're already using it and run into any problems or have any questions or wanting new features, I'm the person that you want to reach out to right now. So I'm going to give an intro to Nomad first for people who aren't familiar with Nomad. I'll go on and give an intro to Spark for people who aren't familiar with Spark, and then I'll talk about the integration. So Nomad is an easy and flexible container orchestration tool designed to enable an organization to deploy and manage any containerized or legacy application using a single unified workflow. So Nomad can run a diverse workload of containerized, legacy, microservice, batch processing applications. It's intended to be able to run whatever you want to run. It's scalable both in terms of the organization of Nomad clusters and in terms of their performance. It has native support for multi-region and multi-cloud federation, and it has native integration with other tools in the HashiCorp stack. So console for service discovery and runtime configuration, both of Nomad and application workloads running under Nomad, and integration with HashiCorp Vault for secrets management. And the job specifications are written using HashiCorp configuration language, HCL, just like you would use with Terraform. And there's a Nomad provider for Terraform. So it's one part of, but a full participant in the larger HashiCorp stack that you guys may already be familiar with. So I mentioned it was easy. One of the most important features of Nomad is the relative ease to deploy and operate a Nomad cluster. So it's actually deployed as a single binary that can run either in client mode or server mode. In client mode, the clients register with the servers and do what you might expect clients to do. They wait around for work to be assigned. They execute those tasks, and then they monitor them. Servers, on the other hand, manage the global state of the cluster and perform the work of scheduling tasks to clients. So 3 or more servers can form a highly available control plan to handle scheduling. And the servers store the state internally and use a raft-based consensus protocol for state replication for automatic leader election. And one of the benefits of that is it makes Nomad highly available out of the box. And it does it without any external dependencies on systems like etcd or Zookeeper, for example. So this is built into Nomad. So a single logical cluster defines a region which can contain multiple data centers useful for high availability. And then multiple regions can be easily federated together. In fact, to do federation of multiple regions is actually just a single CLI command. And if you're using console, this can actually be automatically discovered. And at that point, Nomad will use a gossip protocol for cross-region cluster membership and failure detection. And this allows work to be scheduled across region boundaries. So in addition to the ease of operation, Nomad is extremely performant. It was designed from the ground up to support global scale infrastructure. So the default scheduling mechanism uses bin packing to maximize application density, to increase clutter utilization, decrease infrastructure costs. State replication and automatic failover that I just mentioned, plus the cross data center scheduling, mean that the control plane and user workloads are highly available in the face of failures. And multi-region federation adds to this reliability by creating a globally accessible job scheduler. So Nomad clusters easily scale to thousands of nodes. In fact, Nomad has been proven to scale to cluster sizes that exceed 10,000 nodes in real-world production environments. Furthermore, the scheduling architecture itself is designed to operate at extreme scales. Scheduling in Nomad uses an optimistically concurrent scheduling strategy. The work is spread across all of the servers. And the result of that is it actually can yield thousands of job deployments per second. If you're curious about that, there's actually a good example up on the HashiCorp website. Just Google Nomad 1 million container challenge. So at the end, this is very interesting to me when I came to the Nomad team. It's every single part of the scheduling operation in Nomad is taking all of these different axes, the number of clusters, the size of the cluster, the number of jobs, and just trying to take that order in work and just break it wherever possible. I'll log in here, something over there. So really at its core, it's just completely and totally dedicated towards trying to be as efficient at scale as possible. And as a result, it's no surprise that Nomad is trusted by enterprise customers to run production workloads at scale, both across their private infrastructure and in public cloud providers. And the last of these, and this is really the most enjoyable one. I mean, it's nice that it's fast and it's great that it's easy, but it's the flexibility of Nomad. It was designed to fit your workload and your infrastructure to run any workload on any platform. So we release binaries for Linux, Windows, and Mac OS. And I'm going to get them to start I'm going to try to get them to start doing FreeBSD again. Out of the box, Nomad supports multiple workload runtimes. We call these task drivers. So whether your workload is containerized or not, Nomad is going to have a task driver to allow you to run it. So if it's a Docker container, maybe you've got a legacy standalone binary or a Java application in a jar, it's simply a matter of specifying the target runtime in the job specification and clicking submit. And the work will be scheduled to a client which has the appropriate operating system, satisfies all the constraints, has the appropriate task driver, and it'll run it. And the best part is that as of the upcoming release of Nomad 0.9, users can actually extend Nomad to fit their use case by providing task driver plugins. So this allows you to support custom runtimes. Maybe if you do get that FreeBSD Nomad binary, you can add a task driver for FreeBSD jails. Or maybe you just want to support an existing PaaS provider. Maybe you work at a company where you have an internal container as a service or platform as a service offering. You can do that. Similarly, Nomad has flexible hardware support via what we call device plugins. The first device plugin, in fact, that we're supporting is for NVIDIA GPUs, which allows workload to be scheduled across GPU-optimized clusters. You can imagine this is a very big ask, especially in the context of this Apache Spark work. However, additional plugins can be added to support any desired hardware. For example, if you have tensor processing units or FPGAs or whatever custom hardware you may have and want to explore and schedule work to. Any number of things that we couldn't anticipate. And the best part about this is that all of our internal runtime and all of our internal device plugins have been rewritten as plugins. So we use the same system. We ship these with us, but it means that user-provided plugins have first-class support in the job specification and in the scheduler. So that's Nomad. That's enough about Nomad. What about Apache Spark? So Apache Spark is a general-purpose cluster computing system. It's built on top of the Spark Core API. It supports distributed batch and streaming computations. It provides high-level APIs in a number of different languages: Java, Scala, Python, and R. It's actually written in Scala. And in this core API, you code against what's called an RDD, a resilient distributed data set, this structure. And this is what Spark is concerned with. It's concerned with resilient the storage of data and the ability to do distributed computation on that. It provides optimized engine that supports general execution graphs, in-memory processing, data reuse. And what this does is it allows efficient computation of workloads that didn't really work very well in previous compute models like MapReduce. On top of all of this, Spark provides a rich set of higher level libraries. And this is where actually some of my own interest in Spark is in some of these. Some of these are, for example, Spark SQL for SQL and structured data processing. MLlib is a machine learning library built on top of Spark Core. GraphX for graph processing. and Spark streaming. So it could be run in a standalone mode pretty easy, and upstream Spark, Spark is an open source project, supports a number of different cluster managers. Yarn, Mesos, and Kubernetes was added in, I think, 2.3 of Spark. So why am I talking about Nomad and Spark? Well, Nomad's design makes it well suited to run analytical applications. We already have the support for running native batch applications inside of Nomad. It's something that's used by a number of our customers. First, Nomad has a proven capability to support cluster sizes necessary for the largest analytic workloads. And particularly relevant is the extreme scalability of Nomad, the native support for batch workloads, and parallelized high throughput scheduling. Furthermore, Nomad's easy to set up and use, which has the potential to ease the learning curve and operational burden for Spark users who might not be otherwise interested in the day-to-day task of managing a distributed compute cluster. You know, if you're setting up a Kubernetes cluster just to run your Spark jobs, you're doing a lot of work for a lot of the capability that Kubernetes provides, but that Spark workloads don't require. So, you know, if you're looking at doing something like that, I'd tell you to consider one of the other workload orchestrators, and I would recommend Nomad, of course. Now, of course, for larger IoT operations, Nomad's robust scheduling system and diverse runtime support means that you don't need to create a separate cluster just for Spark applications, allowing enterprise customers to cut down on infrastructure costs. Most notably, Spark Nomad was written on requests from some of our client and partner organizations that were already using Nomad for their application workloads and wanted to run their analytics pipelines on their existing Nomad infrastructure. And lastly, and this is one of the ones that I'm especially excited about, is the new support for extensible device plugins in Nomad 0.9 means that scheduling Spark jobs using novel hardware accelerators is uniquely possible with the Nomad-Spark integration. So how do you get Spark on Nomad? Well, I mentioned earlier that, that upstream Nomad has a couple of different external cluster managers that it supports. Unfortunately, right now, Spark doesn't provide a pluggable cluster manager system. So this is something that is in the works. It's something that hopefully we can get done. In the meantime, what we have is HashiCorp provides an open source fork of Spark called Nomad-Spark. It's up in GitHub. And we regularly release Spark jar distributions as well as Docker images. The latter one's actually notable because, as you recall, Nomad has a lot of flexibility with what type of workloads it can run. It can run a Java application, it can run a raw executable, it can run Docker containers. So depending on how you have your Nomad cluster configured or what sort of customization you want to do to your Spark distribution, you have the ability to customize that either by using a custom distribution or one of these modified Docker images. So in December, we released Spark 2.4.0 targeting the Nomad 0.8.6 API. That's the last release of Nomad. Although I'll tell you that the scheduler in Nomad-Spark is typically forward compatible with Nomad APIs. And as soon as Nomad 0.9 is released officially in the next couple of weeks, I'll actually be releasing a new version of Spark with support for those APIs. So how does it actually work? Well, for the most part, running Spark jobs in Nomad is exactly the same as it is for other cluster schedulers. When running on Nomad, the Spark executors that run the tasks for your Spark application, and optionally the application driver itself, they're going to run as Nomad tasks inside of a Nomad job on the Nomad cluster. So if the Spark application driver is running in the Nomad cluster, this is referred to as cluster mode. That means that when you run Spark submit on the submitter machine, it's actually going to communicate, it's going to invoke the cluster manager inside of the Spark distribution and run the driver up on the cluster. And then it's going to communicate with Nomad to start running the executors as needed. Otherwise, in the default client mode, the driver stays resident on the submitter machine, and then it communicates with the Nomad cluster. Now, cluster mode has the benefit that the Spark submit command can detach, and it doesn't require that the executors have to have network access to the driver. So if you just want to run a job and keep going, you can do that. Client mode, on the other hand, stays attached and is therefore more appropriate when using the Spark RAPL. I'm going to check chat real quick. Just making sure it wasn't anything important. So submitting a Spark job, like I said, is the same for Nomad as it is for any other one of these executors. In this example, the bundled Spark submit command is used to run this standard Spark hello world, a Spark pi. It computes pi inefficiently and horribly. It's not a very good algorithm. But it runs the standard Spark pi sample application against Nomad in cluster mode. So if we look here, I run Spark submit. I indicate what class is a class that defines my Spark application. And then you see just the single option here, master Nomad. This tells it that when it's actually time to start running work, that the cluster manager that should be used is Nomad. You can put a URL in there for your Nomad cluster or look in your environment in the typical way that Nomad does to actually find the environment variables, tokens, and everything else that it needs to communicate with Nomad. In this case, I said deploy mode cluster. Like I said, the Nomad-Spark integration supports both cluster and client deploy modes. And then the rest of it is just information about how to get Spark for these executors and where to find the source code or the binary for the Spark application. So depending on the options past the command line, Spark submit may continue to monitor the job or it may detach, which is likely preferable for long-running analytic pipelines. And I'll actually go over some of those options here. These are some of the notable job options. Now, all of the typical options are going to be passed through to the Nomad orchestration, but some of these I think are notable and they illustrate some of the differences. Spark Nomad, you can specify the CPU utilization for the driver of the executor and the memory. Spark executors instances is actually, if you have a static idea of how many instances you want for your job, this is where you specify that. This is contrasted against dynamic allocation. You can actually just indicate that you would like the Nomad compute engine to scale up and down the number of instances based on the amount of work that needs to be done. And the Nomad scheduling, the Nomad cluster manager supports that. A nice one that we have is Spark Nomad Cluster Monitor Until. And this indicates actually that on the submitter's machine, when you run Spark Submit, how long it should actually monitor the job that you submitted. So if you just want to submit the job, fire and forget and go away, you can do that. Another option is to watch and wait until it's been scheduled. This is nice if you want to make sure it's actually running. The difference between submitted and scheduled is typically a matter of milliseconds for Nomad because it is such a fast scheduler. But if your cluster is overutilized and there's no room to place your jobs, then this is something you might like to know about before you go to launch. And then obviously you have the ability to continue to monitor the job until it's complete. And Spark Nomad Priority, as I mentioned, Nomad is a full-fledged scheduler, and it has a number of features that are necessary if you're going to be using this in production. You don't want maybe some experimental or non-critical analytics pipeline interrupting your production workload like your website. So Priority allows you to specify what the task priority is for these executive jobs. Or maybe you do, or maybe you want to have relative priority of your Spark job. So you have the ability to do that right here. And then you remember we talked earlier about multi-data center support for a single Nomad cluster and then multi-region federation. Those are available as well. So I can run with these options to indicate that I want it run in my private cloud, or I want it run in Amazon, my Nomad cluster up in Amazon, or my Nomad cluster up in this region of Amazon, or over in Google, or wherever. If you have a multi-region or multi-data center Spark infrastructure, this allows you to target your jobs to that, as simple as passing in this command line argument. And then the last one is actually, I think, one of the nicest parts and the most unique parts about the Nomad-Spark integration is that we have the ability to pass in a custom template for the Nomad job specification. So if you've used Nomad before, you'll recognize that this is a job specification. It specifies the job, task groups, and then the tasks that actually make up those groups. And it's written in HCL. So if you've used pretty much any of the HashiCorp products, you're going to recognize this. And job templates here can be used to customize the job specification that is ultimately submitted to the Nomad cluster to run your Spark application. So what this is going to do is going to allow users, for example, to add metadata about the job, or constraints, or if you have placement preferences. Maybe you want a little bit extra HA in your Spark application. You want to spread your executors across 2 data centers inside of a cluster. If you want to customize the tasks that are the run configuration for the tasks, for example, or if you want to set special environment variables, if you want to add sidecar containers with your task for log shipping or something like that. If we're talking about adding support for custom hardware accelerators, Spark doesn't know about a lot of these things. Spark doesn't know that your company has custom FPGAs inside of the data center. But if you write a Nomad device plugin that can fingerprint and detect and report back to the scheduler, report back to the servers that you have these sorts of things available, the servers can actually schedule jobs to use that custom hardware. So how do you do that in Spark if Spark doesn't know about it? Well, you put it inside the job specification here. You expand this template out to have to list that you need additional resource allocation for your custom hardware, the same as you would do for CPU or memory or network bandwidth. And that allows you to use, just to completely and totally tailor this to your workload. If you need to use console or Vault integrations, just about anything else you could want to do with a Nomad job specification, you can do using the Spark integration. And it provides a near complete ability to customize the execution of the tasks in the Nomad cluster. So in summary, Nomad is a flexible, scalable, and performant workload orchestration tool. It was designed this way for the purpose of running production services and batch jobs at a global scale. These same characteristics, unsurprisingly, which make it successful at running non-Arc Spark applications, speak to its suitability for running Spark applications. It's simpler than most of the other cluster managers to provision, to operate, and to scale. And while this is a nice feature in general, it is especially significant for users who are only interested in Spark workloads. Of course, if you're already using Nomad, or if you're looking at running multiple types of workloads in addition to Spark, you should look at running Spark on Nomad. So if you want to get started at this, please just Google Nomad-Spark, see the Nomad-Spark project on GitHub. There's plenty of documentation there. There's also guides for the Nomad-Spark integration on the Nomad project website. And feel free to reach out to me on GitHub in the issue tracker, on Twitter, or via email if you have any questions or feature requests or anything else related to this. And then lastly, thank you for attending this HashiTalk and all the HashiTalks today. And if you want to learn more about Nomad, Preetha Apan, the engineering manager for the Nomad team, will be giving a talk in a few hours on job preemption in Nomad. This is an especially important topic in the context of Nomad-Spark, for example, if you're running high priority service and system workloads and they're competing with low priority batch jobs like Spark. So if you're interested in learning more about scheduling in general or scheduling in Nomad in particular, you should consider attending this talk.